Hi everyone, welcome to Build a Spotify Connected App. My name is Brittany Chiang and I'll be your instructor for this course. I've been building stuff for the web for over 6 years, and along the way I've learned a ton of tips and tricks that I'm going to share with you over the next 7 modules. We're going to be covering a lot of ground with this course, and by the end you'll have an app deployed to the internet that you can share with your friends. So who's this course for? This course is for anyone interested in building and deploying a full-stack web application that integrates with the Spotify Web API. Specifically, if you've been struggling with understanding and implementing Spotify's OAuth flow to allow users to log into Spotify in your app, this course is for you. If you're a front-end developer and want to gain more experience with back-end web technologies like Node.js, Express, and third-party APIs, this course is for you too. To get the most out of this course, you'll want to have a few things under your belt first. First, an intermediate understanding of HTML, CSS, and ES6 JavaScript. Second, basic knowledge of the React framework and React hooks. And third, a Spotify account. You can totally create a Spotify account right now if you don't have one, but the app is going to be a lot more interesting if you've accumulated some Spotify history already. So what we're going to be building in this course is a web app to visualize personalized Spotify data. We're going to do this with the help of Node.js, Express, React, style components, and the Spotify API. The Spotify API makes a lot of interesting data available that isn't readily accessible to the general public. For example, your top tracks and artists of all time, audio features like danceability and tempo for individual tracks, and dynamic recommendations based on a given set of tracks. The goal of our app is going to be to leverage the Spotify Web API to provide users with more of their personalized Spotify data, kind of like the data you get from your Spotify Wrapped Year in Review. On the front end, we'll build out a professional responsive user interface with React, React hooks, and the popular CSS and JS library style components. We'll pull in data from the Spotify API using modern ES6 async await methods and display that data in an engaging way. On the back end, we'll learn the basics of REST APIs, HTTP requests, and OAuth. We'll lift the veil on how to authorize an app with Spotify, and then build a Node server with the Express framework to handle our authentication requests. Finally, we'll deploy our app to the internet using Heroku. So if you've ever checked out your profile page on Spotify, you'll see that they have some interesting information such as your top artists and top tracks. Our app is going to be very similar to this. You can check out a final demo of the app at spotifyprofile.v2.herokuapp.com. Here, we let users log into Spotify, and then once they're logged in, they can see their top artists, their top tracks, and their playlists. They are also able to see the different time ranges for their top artists or top tracks, like their top artist in the last 6 months, all time, or just the past 4 weeks. For playlists, they will be able to check out a playlist and sort the tracks by different audio features like danceability, tempo, or energy. And like I mentioned before, we're going to be accomplishing this with the help of Node.js, Express, React, style components, and of course, the Spotify API. So, what are we going to learn in this course? In Module 0, the module you're in, we're going to be setting up our development environments. In Module 1, we're going to be learning the basics of APIs and REST principles and how they're relevant to the way we're going to interact with the Spotify API later in this course. Then we'll introduce the Express framework and learn the basics of how to handle HTTP requests with Express route handlers. In Module 2, we'll learn all about OAuth and how it relates to the various authorization flows that are possible with Spotify. Then we'll implement Spotify's authorization code flow with our Express app by creating route handlers to interact with the Spotify account service. Once that's all wired up, we'll use our newly acquired Spotify authorization token to test out how to request user data from the Spotify Web API. In Module 3, we'll set up a React app for the front end of our app. We'll configure our project to handle 2 package.json files and update our workflow to run both client-side and server-side code at the same time. We'll also learn how to pass the Spotify OAuth access token we retrieved from the previous module from our Node server to our React app. In Module 4, we'll learn how to store our Spotify access token in local storage so users don't have to go through the auth flow every time they visit our app. We'll also set up a way to automatically refresh the access token when it expires without interrupting the user experience. Additionally, we'll set up our first API call from the React app to the Spotify API and display data from the response in our template. Then we'll set up React Router and style components to scaffold out our front-end architecture. In Module 5, we'll be putting in some work to build out our React app. We'll use style components to style our UI and then add some features leveraging the Spotify API that the Spotify app doesn't provide out of the box. This will include things like sorting playlists by audio features and toggling between different time frames for calculating your top artists and top tracks. In Module 6, we're going to go through the steps on how to prepare our app for production and deploy it to the internet with Heroku. And then in Module 7, we'll wrap up what we've learned in this course. At the beginning of each module, there will be a zip file available with the completed code from the previous module. So if you're having trouble with the code for Module 2, look to the code in the zip file at the start of Module 3 for the answer. Of course, if you ever have a question or are stuck on a lesson, you can comment in line or ask in the Newline Discord. The link will be in the manuscript below. Thanks for checking out this course, and I'm so excited to have you here. Let's get started. Alright, so before we dive into coding, we're going to make sure our development environments are all set up. So I'm going to be using VS Code or Visual Studio Code for this course, but you're totally free to use whichever code editor you're most comfortable with. The theme I'm using is Halcyon theme, which I made myself, and this is available on Visual Studio Marketplace if you want to grab it. And the font I'm using is Fira Code. And for my terminal, I'm using iTerm2, and I'm using the spaceship prompt, which is what gives me this cool little arrow, and it tells me what branch I'm on. It also tells me cool things like the node version, package version, and time. And in addition to a spaceship theme, I'm also using some custom colors that I kind of predefined myself based on my Halcyon theme, and you can grab it here if you'd like. So the next thing we're going to want to do is install a tool called NVM, which stands for Node Version Manager. This is a tool, a CLI tool, that makes it super easy to switch between different node versions when you're working locally between JavaScript projects. And the way it works is basically you define a NVM.rc file in each project, and whoever uses your project or clones your project can use that NVM.rc file to install the right node version with the NVM CLI. So to install NVM, you can find this GitHub repository with a quick Google, but this is the official NVM repository. And if you scroll down and if we visit install and update script, there's this script that they provide to install NVM on your machine. So I would recommend coming here and copying this curl command, and in your terminal you can paste it in and hit enter. It doesn't really matter if you're seeded into a project or not, as long as you're in your terminal. It should be fine. So once that finishes, you can see it says close and reopen your terminal to start using NVM, or run the following to use it now. And this is this snippet, it automatically gets put into your bash config or your ZSH config, depending on what you use. But I would recommend doing what they say and restarting your terminal to make sure it's all installed. And as you can see, it says for me that NVM is already installed. So if I type nvm -- version, you can see that I have 0338, and the latest is 380. So make sure that NVM version prints out a version number for you. And next, we should make sure that Node also came along with NVM. So to make sure that's installed, you can type node-v and make sure it prints a version as well. And in addition to Node, we can also make sure that we have npm properly installed with npm-v. And again, I am using this Node version 14.15.0 and this npm version in this project, but as long as you have a Node version that's greater than Node 10, you should be fine. And I would recommend upgrading to npm 7 if you're not already on it, but if you're not, you can simply type npm install-g npm at latest to get the latest version of npm. Alright, so the next thing we want to do is set up a new project directory for the code that we're going to be writing for this app. So in your terminal or however you're comfortable, create a new folder on your computer, wherever you like to keep your projects. So we're going to type make dir newline Spotify app, and it doesn't have to be newline-Spotify app. It could be any descriptive name you want. But once you create it, cd into it, and then we're going to use the npm init-y command to create a new empty package.json file in the directory. And then after that, we're going to create a nvmrc file like we talked about before. And then if we pop open our new project in VS Code, we can go to our nvmrc file and then specify which Node version we want to be using. So since I'm currently on 14.15.0, I'll just type that in here. So now if there's anyone who wants to clone your project or something like that, they can, as long as they have NVM properly installed on their machine, come in to your project, cd into it, and type nvm install, and that will make sure that they're on Node 14.15.0, regardless of what Node version they were on before. Alright, so lastly, we're going to create a gitignore file, just to make sure that once we start committing things to source control, sensitive or unnecessary files like node modules or environment files aren't committed and pushed up to a public repository. So in here, we'll just add dsstore and node modules. All right, now we're ready to go. All right, so module 1, getting started with REST APIs and Express. So in the last module, we got our development environment set up with Node and NVM. And in this module, we're going to be learning the basics of APIs and REST principles and how they're relevant to the way we're going to interact with the Spotify API later in this course. We're going to introduce the Express framework, and we'll also learn the basics of how to handle HTTP requests with Express route handlers. We're going to cover the difference between regular APIs and REST APIs, the basics of REST principles, the anatomy of REST API requests and responses and how they relate to the Spotify API. Then we're going to learn how Express fits in with Node.js, how to create a simple Node server with Express, and how to handle HTTP requests and responses with Express. All right, let's get going. Okay, so what is an API? API stands for Application Programming Interface. And basically, it's a set of rules that allow one piece of software to talk to another. It's kind of like a contract that defines how a consumer is going to make requests and then what they're going to receive in return. APIs also make our lives easier by abstracting away complex code and replacing it with simpler, more straightforward code. So for example, think about what happens when you open the Spotify app and play a song. There's probably some code that runs when you click play that looks something like this. So here, this play function is an API method that abstracts away things like the code needed to retrieve the audio file from the internet or your device, or the code needed to send audio data to your device. And as developers, we don't really need to know or care about the lower level code that gets executed when we call the play method, and that's totally fine. APIs are here to make our lives easier. So how do APIs work? In client-side JavaScript, APIs are usually based on objects. In the pseudocode example that we saw with the play function, the media player object was the entry point for that API. And we can assume that the media player object also exposes other API methods, for example, maybe a pause method. So let's take a look at a more practical example that you've probably encountered before. So if you've ever written JavaScript that looks a little bit like this with a document.querySelector method, then you've used an API. You've used the DOM API or Document Object Model API. So in this code snippet, the document object is being used as the entry point for the DOM API, and the query selector is the method. It's important to note that these APIs aren't a part of the JavaScript language, but rather they're built on top of JavaScript to give developers a convenient set of tools out of the box. So in the web development world, APIs generally fall into two categories: browser APIs and third-party APIs. So browser APIs are built into your web browser, like Chrome or Safari, and they expose data from the browser and surrounding computer environment that developers can easily leverage. The most common browser API is the DOM API, which we mentioned before. It lets you manipulate HTML and CSS. It lets you create, remove, and change HTML, and you can do cool things like dynamically apply styles or animate elements on the page. And there's a huge list of other browser APIs, but another notable one is the Web Audio API. And you can probably guess that this API lets you manipulate audio in your browser. You can do really interesting things like alter the volume of a track, apply different effects to it, etc. And this API abstracts away all of the complex lower level code that you can imagine is doing the actual audio processing, so you can focus on building something cool. On the other hand, third-party APIs are not built into the browser by default, and you generally have to retrieve their code and information from somewhere on the internet. For example, the Twitter API allows you to do things like display your latest tweets or retrieve other people's tweets. And similarly, the Spotify API allows you to do things like display your top artists and tracks of all time, or view your different playlists or their tracks. We'll be diving into this soon. If you'd like to further solidify your knowledge of web and browser APIs, I would highly recommend you reading the MDN documentation. In the next module, we're going to learn a little bit about REST APIs and REST principles. So when people talk about third-party APIs like the Spotify API, the Twitter API, or the GitHub API, what they're really talking about is a REST API. REST stands for Representational State Transfer. So if an API is a set of rules that allows one piece of software to talk to another, then REST is a standard set of rules that developers follow to create an API. These rules determine what the API looks like. So for an API to be considered RESTful, there are certain criteria that need to be met. So the first of these criteria is client-server. The API should be able to enable a client-server architecture made up of clients, servers, resources, etc., with requests managed through HTTP. So when System A makes an HTTP request to a URL hosted by System B server should return a response. The second criteria is stateless. All requests should be independent of each other. It should be possible to make 2 or more HTTP requests in any order with the same responses being received. Third, it should be cacheable. The API should make data cacheable to streamline client-server interactions. Fourth, uniform interface. There needs to be a uniform interface between components so that information is transferred in a standard form. Fifth, it needs to be layered. The requesting client doesn't need to know whether it's communicating with the actual server, a proxy, or any other intermediary. And lastly, code on demand. The API allows executable code to be sent from the server to the client when requested, extending client functionality. So first, let's talk about RESTful requests. In simple terms, the client-server rule of RESTful APIs means that you should be able to receive a piece of data, also known as a resource, when you access a predefined URL. Each of these URLs, also known as endpoints, are part of what is called a request, and the data you receive from the request is called a response. The resources provided by these responses are usually in the form of JavaScript object notation, or JSON. So a RESTful request is composed of 4 parts. First, the endpoint URL, then the HTTP method, the HTTP headers, and then the body data. Let's dive a little deeper and look into these 4 parts of requests. So the first thing we have is the endpoint. The endpoint is the URL you request. All REST APIs have a base URL, also known as the root endpoint. For example, the base URL of Spotify's API is api.spotify.com. And other APIs like the GitHub API have root endpoints that are api.github.com. Additionally, each endpoint in a REST API has a path that determines the resource being requested. So in this case, this endpoint from the Spotify API returns data for a playlist based on the ID you provide. In this case, it's this 59Z string at the end. And note that v1 in this Spotify API base URL is not part of the path. It's a common convention for APIs to add a version indicator like /v1 to their base URL, so that if there's breaking or major changes in the future, a new v2 base URL can be created, leaving the v1 API available for use. Some endpoints also support query parameters, and query parameters give you the option to modify your request with key value pairs. They always come after the main URL you're requesting and begin with a question mark, right here. Each key value pair is specified with an equal sign, and each parameter pair is separated with an ampersand. So query 1 and value 1 is one pair, and query 2 and value 2 is another pair. Query parameter values can sometimes be a list of things, and in these cases it's common to use comma-separated lists. So endpoints are just like any other URL you visit on the web, but instead of returning data for a website, they return resources, data like JSON or XML. The second part of the RESTful request is the HTTP method. This method is the type of request you send to the server. And there are 5 common types of HTTP methods. There's get, post, put, patch, and delete. And they're used to perform 4 possible operations: create, read, update, and delete. CRUD, as you may have heard before. So first we have get. Get retrieves or reads resources. Post creates resources. Put and patch both update resources. And delete, as you can imagine, deletes resources. When working with a REST API, the documentation should tell you which HTTP method to use with each request. So for example, this getPlaylist endpoint on the Spotify API will tell you that this endpoint is accessed with a GET request. The resource that this endpoint returns is some JSON about a specific playlist, and we'll touch more on this below, but there's a ton of data in this JSON object that we can use on the front end. The third part of RESTful requests is the HTTP headers. HTTP request headers are used to provide information to both the client and server. You can store things like authentication tokens, cookies, or other metadata in HTTP headers. In our app, we'll be sending along basic authorization headers in our HTTP requests so that the Spotify API can authorize our requests. Headers are key value pairs that are separated by a colon. And the example below shows a header that tells the server to expect JSON content. The key here is content type and the value is application/JSON. If you want to learn more about HTTP headers, you can visit the MDN documentation. There are a ton of headers such as authentication headers, caching headers, client hints, etc. The fourth and final part of RESTful requests is the body data. So the body of a request contains any information you want to send to the server. And since GET requests don't need any extra information from you to return existing resources, only post, put, patch, or delete requests can have body data. And the body data you send along with these requests is usually the data you'd like to create a new resource with, for example with a post request, or the modified value of a resource you'd like to update, for example with put or patch requests. And data is normally transmitted in the HTTP request body by sending a single JSON encoded data string. And if this doesn't make sense to you right now, that's totally fine. We'll go over some of the more hands-on examples soon. So now that we've covered RESTful requests, let's talk a little bit about RESTful responses. So like we mentioned before, REST API responses usually return resources in the form of JSON. Like we saw before, this is the getAPlaylist API endpoint on the Spotify API. And the JSON that this endpoint returns has a bunch of data that is really interesting that we can use on the front end. For example, there is the playlist image, the name, the different tracks on the playlist, and each track has its own information such as when it was added, the available markets, and each track's specific image. And this is all information we're going to leverage and use to display our front end when we start building out our app. The last thing we need to know about RESTful responses are HTTP status codes. So every REST API response includes an HTTP status code in the response header. These status codes are numbers that indicate whether a request was successfully completed and range from the hundreds to the 500s. In general, the status codes fall into these categories. So 100 plus is an informational response. 200 plus is a request has succeeded. 300 plus is request has redirected to another URL. 400 plus is an error that originates from the client, and 500 plus is an error that originates from the server. Alright, so now that we've learned a little bit about RESTful requests and responses, in the next module we're going to start looking into Express, a framework in which we can actually start writing our own RESTful APIs. Okay, so now that we know how REST APIs are supposed to work, let's learn a little about which tools we could use to build one with JavaScript, like Express. Express is a popular framework for Node.js designed for building web applications. At its core, it provides HTTP utility methods and middleware for developers to easily create powerful APIs. Express makes it easy to do things like write handlers for requests with different HTTP verbs like get, post, put, delete, etc. at different URL paths or routes. Here, this put request is on the /user route. Express also makes it easy to integrate with view rendering engines such as Pug, Mustache, EJS, etc. to dynamically generate responses to requests. Additionally, Express lets you write request processing middleware at any point within the request handling pipeline to handle things like authentication, cookies, URL parameters, and more. And of course, all of these things could be accomplished with plain Node.js, but Express provides developers with a great deal of convenience, saving us time and making our lives easier. Express isn't the only Node framework out there that provides these kinds of features. At the time of recording, Fastify and Koa are two popular alternatives. Since Express is such an industry standard, we're going to be using it to build our app. So first, our package.json file should look something like this. We'll open up our terminal and npm install Express as a dependency. Once Express has finished installing, you should see Express listed as a dependency in your package.json. Next, let's create an index.js file as our entry point. And at the top of the file, we're going to require the Express module and instantiate our Express app. And below that, we're going to add a simple route handler for our index page. And we'll just send back hello world. So the code snippet here tells our Express app to do two things: handle a GET request on the home page or the index route, and then send a hello world string back with the response. Next, we'll tell our Express app to listen for a connection on a port. We'll tell our app to listen on port 8888. And when it does listen, we'll just write a little message saying it was successful. Now let's run our app locally with our terminal. All we have to do is use the node command. And as you can see, our console log is showing up here. And if we visit localhost 8888, we should see hello world. Awesome. In the next lesson, we'll dive a little deeper into the way Express works. And if you're wondering, if you ever want to tell your app to stop listening on localhost 8888, you can just type Control-C. One of the most basic concepts in Express is routing. When a user goes to a URL or makes a request to an endpoint, we need to define what happens behind the scenes when the user hits that endpoint, as well as what they get back as a response. For example, when a user hits an endpoint, we might want to query a database for information or modify data in some way, or create a new instance of something, like posting a new picture on Instagram. With Express apps, every route definition is structured like this: app.method with a path argument and a handler argument. App is an Express instance, like we have up here. The method is an HTTP request method, and in this case, it's lowercase get, post, put, or anything like delete. Path is a URL path on the server, like the index path. And handler is a callback function that is run every time a user hits a specific URL, this function. The callback function takes a request, rec, and a response, res, as arguments. And you can use argument names other than rec and res in the callback function, but no matter what you call them, the first argument is always going to be the request, and the second argument is always going to be the response. In the index route handler we wrote in the last lesson, the callback function takes res.send to return the string hello world as the route's response. There are a bunch of other response methods for ending the request-response cycle other than res.send. For example, you could call res.json to return some JSON as a response, or res.sendFile to send a file as a response. If we update our homepage route to return some JSON instead of hello world, it would look something like this. Then, when you restart your server and visit localhost 8888 in your browser, you should see the JSON response. Res.json is probably the response method you'll use most often, so keep it in mind. The rec argument of the callback function is an object. This object contains information about what's coming in with the request. Some of the properties that you can find on the request object are request.body, which contains key value pairs of data submitted in the request body, Rec.method contains a string corresponding to the HTTP method of the request, like get, post, put, and so on. Rec.params contains an object with properties mapped to the named route parameters. So if there's a name parameter at the end of this user route, we can get it with rec.params.name. And rec.query is an object containing a property for each query string parameter in the route. Rec.query is a property that's commonly utilized in route handlers. A simple example would be using the endpoint's query parameters, the key value pairs following the question mark in the URL, to dynamically generate a response. Let's take a look at an example. So if we add this route handler for the awesome generator route in our index.js file, then restart our server, and in our localhost, visit awesome-generator and pass it two query parameters, name and is awesome. In this case, I have name equals Brittany and is awesome equals true. And you can see that the response says Brittany is really awesome. In our route handler, we use destructuring to grab the name and is awesome properties off of the rec.query object. Then we dynamically generate the string to send back with template strings. If is awesome is true, then the string will end with really awesome. If it's false, it'll end with not awesome. Note that we're using json.parse here to parse the value of the isAwesome variable because query parameters always come back as strings, not booleans. So if you take a look at our localhost again, you can see I have the name and isAwesome query parameters here. If I change isAwesome to true, we can see it says Brittany is not awesome. We can also change the name query parameter to something other than Brittany. We can do things like an emoji, and that will come through in the response as well. This simple example shows how Express gives us a bunch of useful tools out of the box for handling HTTP requests and responses to create powerful APIs. Module 2, Authentication and Authorization with Spotify. So in the last module, we learned about REST APIs, HTTP requests, and Express.js route handlers. In this module, we'll learn all about OAuth and how it relates to the various authorization flows that are possible with Spotify. Then we'll implement Spotify's authorization code flow with our Express app by creating route handlers to interact with the Spotify account service. Once that's all wired up, we'll use our newly acquired Spotify authorization token to test out how to request user data from the Spotify web API. We'll cover how to set up the Spotify developer dashboard, what OAuth is and how it works, the basics of Spotify's different authorization flows, and how to implement Spotify's authorization code flow with Express route handlers. Let's get into it. Alright, so let's get started with the Spotify developer dashboard. If you don't have a Spotify account yet, this is the time to make one. You can sign up for free at spotify.com. Once you have a Spotify account, head on over to developer.spotify.com. Then go to Dashboard. Then log in. Once you log in, you should see something like this. And here is where we're going to create an app to get our API keys for our client-side app. So go ahead and click Create an App, give your app a name and a description, and accept the terms of service. Since I already have my app set up, I'm just going to hit cancel here. But when you do create your app, you should be directed to a page that looks something like this. And keep this page in mind, we'll be coming back to it later, but as you can see right now, we have a client ID. If I click this, you can see your client secret. And once we set up our app to hit the Spotify API, you'll be able to see some analytics and stats of what endpoints you've hit and where the users are and how many users you have. Once that's all set up, I would recommend clicking around the developer site of Spotify. So you can go to the Discover tab here and you can see a bunch of different apps that people have made before that use different features of the API, like audio features and analysis, playback, recommendations, etc. Also, take a look at the docs. We'll be using the web API, and there's a lot of documentation here that may not make much sense to you now, but we'll be getting into it. And also go ahead and check out the console. And this is a really useful tool that Spotify has provided to let you play around with each API endpoint. For example, this get an albums track API endpoint, the /albums/ID/tracks is a way for you to get JSON information about an album's tracks. So as long as you have a good OAuth token here, you can hit get token if the one they've provided for you is expired. You can hit fill sample data and then hit try it. If you scroll down a bit, you can see there's a big JSON response here for that endpoint. And you can see that in the items array, there is an object for each track. And if we scroll down a bit, we can see that there is a bunch of tracks here in this array, but there's also a total of 18 tracks, and this JSON response has been limited to 10 tracks, but we can always hit the next endpoint here to get the next set of tracks. So just click around, play with the different API endpoints, and maybe you'll get inspired to create a Spotify integrated app of your own.